Let's consider the case when a line and a circle coexist in the same plane. There can be three possibilities. In the first case, the line is in the exterior of the circle and hence the line and circle have no common point. When a line does not intersect the circle at all, the line is known as a non-intersecting line with respect to the circle. Next case is when the line intersects the circle at 2 points. In that case, a part of the line lies in the interior of the circle. The 2 points of intersection lie on the circle, and the remaining portion lies in the exterior of the circle. A line that intersects the circle in 2 distinct points is called a secant of the circle. Notice that the portion of the secant that lies inside the circle contains the chord of the circle. Last case is when there is only 1 point in common between the line and the circle. A line that touches a circle at exactly 1 point is called a tangent line. The word tangent means touching. The point where the tangent touches the circle is called the point of contact. In this example, point N is the point of contact of the tangent line AB. Here are a few examples of tangents in our everyday life. Observe that in each of the examples, a straight line is tangent to a circle. Let's learn more about tangents. Let's understand a few properties of tangents to a circle. Here, line EF intersects the circle at 2 distinct points, G and K. Thus, line EF is a secant of the circle. Let's draw another secant PQ that is parallel to secant EF and intersects the circle at points A and B. Point X and point Y lie on the circle. Let's move secant PQ closer to point X. Observe that as line PQ approaches point X, the length of the chord AB decreases. In other words, the distance between points A and B gets lesser and lesser. Finally, the distance between points A and B becomes 0 when the secant PQ touches point X. In other words, points A and B coincide with point X. Notice that now PQ is the tangent to the circle at point X, which is the point of contact. Similarly, let's draw another secant LM parallel to secant EF. Secant LM intersects the circle at points S and T. Now, let's move the secant LM closer to point Y. As you can see, the distance between points S and T gets lesser and lesser as it approaches Y. Finally, the length of chord ST becomes 0. The points S and T coincide with point Y. Thus, LM is tangent to the circle at point Y. This shows that a tangent to a circle is a special case of a secant, when the 2 endpoints of the corresponding chord of the secant coincide. Next, let's draw multiple lines parallel to secant EF on both the sides. How many tangent lines are parallel to secant EF? Only 2 tangent lines LM and PQ are parallel to the secant EF. Thus, we can say that there cannot be more than 2 tangents parallel to a given secant. Now in this circle, line PQ is tangent to the circle and point X is the point of contact. Let's draw a segment from center O to point X so that OX is the radius of the circle. Let's measure the angle OXP. It is a right angle. Explore to see if the radius and tangent line are perpendicular to each other at any point on the circle through the point of contact. As can be seen in the figure, the tangent line is always at right angles to the radius at the point of contact. Thus, we can say that a tangent to a circle is perpendicular to the radius at the point of contact. This is a defining property of a tangent. In fact, a line is said to be a tangent to a circle if it touches the circle at exactly 1 point, and at that point, the tangent is perpendicular to the radius of the circle. Now you identify the tangents and secants in this circle. A tangent touches a circle at only one point, and at that point the tangent is perpendicular to the radius of the circle. In this example, line AB touches the circle at point Y and is perpendicular to radius PY. Thus, AB is a tangent to the circle at point Y. Similarly, line AC touches the circle at point X and is perpendicular to the radius PX. So, AC is a tangent to the circle too. Notice that segment AP also intersects the circle at a point. However, it is not a tangent to the circle because it is not perpendicular to the radius of the circle. Similarly, ray DE is not perpendicular to the radius of the circle and therefore it is not a tangent to the circle. Line GV is a secant of the circle because it intersects the circle at 2 points, Q and S, such that some portion of the line is inside the circle and some portion lies in the exterior of the circle. Notice that the portion that lies inside the circle, that is segment SQ, is a chord. Note that ST is a line segment that has its endpoints on the circle. Thus, ST is a chord and not a secant. How many tangents can be drawn to a circle from a single point? There can be only 3 possibilities in regard to the position of a point with respect to a given circle. A point, say P, may lie inside the circle or on the circumference of the circle or outside the circle. Can you guess how many tangents can be drawn to the circle from point P in each of these cases? Let's draw multiple lines through point P. Look, all the lines passing through point P intersect the circle at 2 points. A tangent must intersect the circle at only one point. Thus, there is no tangent to a circle passing through a point lying inside the circle. Next, we take a point P on the circumference of the circle. Observe that there is one and only one tangent to a circle passing through a point lying on the circle. Now, we take a point P lying outside the circle. Look, PQ and PR are 2 tangents to the circle from point P. If possible, let's try to draw more tangents passing through point P. Observe that we cannot draw more than 2 tangents from this point. So, there are exactly 2 tangents to a circle through a point lying outside the circle.